So for this example, this looks really similar to what we would do in our solving equations unit. Instead of just distributing a plain number, we're now distributing a number and a variable. So what we're going to do is we're going to take that 3x and we're going to multiply it by the first term in the parenthesis and then by the second term in the parenthesis. So still distributive property, just now with our exponent rules. So 3x times x to the 8th, we're going to multiply the 3 and the 8 and make that 24. And then we know x times x, they have those implied exponents of 1. So x times x is represented as x squared. Then I'm going to do the 3x times the 5. 3 times 5 is 15. There's no x to multiply by, but you are still distributing that x to that term. So it would be like x times no other x. So it just stays the x there. Now, one really important thing to note here, now I have two terms. So far, when we've been doing our multiplying rules, our answer has been a monomial. But let me show you what not to do. We cannot say, okay, there's a plus sign now. 24 plus 15 is 39, x to the third. We cannot do that because now that my answer is not a monomial anymore, we have to bring our rules of adding back to our brains. So here we have rules of multiplying when we distribute. Now we have to check rules of adding. Well, way back when, it's been a little while, to add these, they would have to be like terms. But x squared and x are not like terms. So to multiply them, it's fine. But here to add them, we'd have to check for like terms. Now, eventually we will have like terms later on, but for right now, this is as far as we can take it. This is our final answer. So distributing a monomial to a binomial ends up as a binomial since there are no like terms.